Okay, so we did finish 4.1. Section 4.2, addition rule and multiplication rule. So we denote addition rule by P, which is probability of A or B, and A and B can be the events. Okay. So what does this mean? It means that, as the name suggests, or, that means any one event can occur. Okay. So probability that either event A occurs or event B occurs. Event A occurs or else event B occurs is denoted by P of A or B, also called as addition rule. Okay? Every outcome is counted only once. So again, it can be only one event. So this is the formula for addition rule, which says that the probability of A or B occurring will be equal to probability of A event plus probability of B event minus subtracting probability of A and B both. Okay. Now, what is compound event? Compound event is nothing but combining two or simple events is called as compound event. Okay. You know what a simple event is, which means the event which cannot be broken down into further simple events. Okay. What is disjoint or mutually exclusive, also called as mutually exclusive? Now we know that dis means apart, right? So the event which cannot occur at the same time, which are separate, they cannot occur at the same time. For example, if I say that today it will rain and it doesn't rain, so you cannot combine those two events, right? When I say it rains, you can probably assume that it doesn't rain event cannot be brought into that, right? It is both a separate events. Now event A, event B are the two events. Now if I select someone who is a male, now I cannot select the same person as a female, right? It cannot occur at the same time. I am supposed to choose only one person. It could be male or female. It cannot be both. That means events cannot occur at the same time. So those events are called as mutually exclusive events, or also called as disjoint events. Okay. Now events that are not disjoints are called as not mutually exclusive. So if I choose someone from the statistic class, that could be a female also, right? There is no restriction that it cannot be a female. So it means that the selected person can be a female and that female can be in the statistic course. So events can occur at the same time, are called as events that are not disjoint or not mutually exclusive. Right? Now this is called as Venn diagram. You don't have to learn this, but this is just a representation of what we studied now. Now let us assume that pink one is a A event, B is blue. Okay. Now if I'm combining them, that means they can occur at the same time. Now if I'm combining them, I can denote this as A and B. Now if I say that let's say I have 1, 2, 3, 4, 2, 4, 5, 6. Now imagine moving this pink box into the blue box, which means this 2 and 4 will overlap on this 2 and 4. So these numbers are there in the event A and also in the event B. And if you move the pink box onto the blue box, this is the result. So this is 2, 4, 1, 3, 5, 6. Okay. Now, for example, if I say 7, 8, now you cannot move that box because you can see there is no common present in both the events. You cannot move this box. You cannot overlap. Okay. So when you cannot overlap, those events are called as mutually exclusive. That means the events cannot occur at the same time. So this is called as not mutually exclusive or not disjoint. Sure. Now you can see the formula for those cases. If it is not disjoint, it is P of A or B, that is the addition rule. If it is the mutually exclusive, then that is the again addition rule, but the difference is you will not have this part. Okay, you can easily denote here. When you cannot move the box, there is no common thing present in both the events, so I cannot have P of A and B. Now this can be a common. Okay. Complementary of event, you have already studied that. That means an event which will not occur. Probability of an event which will not occur is denoted by probability of A bar or A complement. The bar on the letter A is called as complement. Rules of complementary events. Probability of A occurring plus probability of A doesn't occur equal to 1. Now, I had said this in the previous section and I did ask you the reason. So why do you think that the event which occurs plus does not occur will be always equal to 1? It will always be equal to 1. Why not 0? We know that probability is between only these two numbers, 0 and 1. It could be 1, 0 or between that. Now they say that this has to be 1, not 0. Why? Okay, let me put it this way. Now I'm going to toss a coin. Tossing a coin once. What is, now this is heads, event A. Event B, I call it as tails. What are the chances that I get event A? What is the probability of getting an event A? 50% or half. Right? Now, what is a probability of getting B event? Half. I'll ask the same question in another way. What is the probability of not getting heads? Right? If I'm not getting heads, that means I'm getting tails. So what is the probability of not getting heads? Half. That means I'm getting tails. So it has to be half. That's why I denoted as P of B. Now we know that not A is equal to half. So this is denoted by A bar, A complement. The event doesn't occur. Now, according to this, let us add P of A plus P of A bar equal to half plus half equal to 1. So if the chance of occurring is 50% and there is 50% chance that the event will not occur, so when you add them both, you will definitely get 1. It could be for any example, okay? And that's the reason it is 1. Right? Now, the other formulas are just shuffling the terms there. If you keep probability of A on one side, and if you move this on the other side, you will get this formula. Okay? Now, those were the rules of complements of A. When tossing two six-sided dice, summing the sides that are face up, let A be the event that the sum has to be greater than or equal to 10. We are saying that there are two dice. Okay, there are two dice. What is the probability that when I add the events of A and B, so A and B is like throwing dice once, B is throwing a dice for the second time. So when I add the result of A and B, I have to get more than 10 or it has to be equal to 10. The sum which I get has to be more than 10 or equal to 10. For example, I can say that the first time I throw a dice, I get say 6. The second time I throw it, I might get 5. When you add these two, the result must be greater than or equal to 10. Okay? Now, for example, if I say 4, first time I get as 4 and the second time I get it as 5, it is not greater than 10 or it is not equal to 10. So this cannot be an event. Okay? Now we have to tell them. So before that, let us write the sample space. What are the sample space? Total outcomes, right? When a coin is tossed, what is the sample space? Heads, comma, tails. So thus that is called as a sample space. Now when a dice is thrown twice, the sample space can be first and second time I get 1, 1, right? Or else I can get 1, 2, 1, 3, 1, 4, 5, 6. So first time I get is number 1, and second time when I throw a dice, it could be anything 1, 2, 3, 4, 5, 6, right? So let us write the sample space. I want you all to write the sample space along with me. Do not see the board, so write and then check whether it is correct or not. 10. Okay, this must be the sample space. Now tell me, if I add these any pair of the numbers, I have to get the sum as greater than or equal to 10. So which part do you think will satisfy this event? If I add 1 plus 1, I get 2, which is false. 1 plus 2, 3. 1 plus 3, 4. Let me come to this end. 6 plus 1, 7. So there is no way I can select from this row. In the same way, check for the minimum value. 2 comma 1 is 3. Last value is 8. I have to get more than 10. I cannot get this row. Right? Next, third row. 6 plus 3 is 9. The highest number possible in that row is 9. Cannot be the event. 4 plus 6, yes, 10, right? But when you add 4 comma 1, I get 5. So not this number, 6, 7, 8, 9. This is the only number where I can get the sum to be equal to 10. Keep checking. 5 comma 1 is 6, 7, 8, 9, 10, and 11. Equal to greater than 10. 7, 8. How am I getting it as 7, 8? Add these two numbers. 6 plus 1 is 7. 6 plus 2 is 8. 6 comma 3 is 9. 6 plus 4 is 10. So this can be the answer. Now if you select any one pair among this, and if you add, the sum will definitely be greater than or equal to 10. Right? So how many pairs do we have? 1, 2, 3, 4, 5, 6. So I have 6 pairs which will obey the event A. Now the remaining numbers are the events which will not occur. I can denote it as a complement. Event does not occur. Answer this question. Find the probability of A. Now we know that probability of A or probability of any event is total outcome by favorable outcome, the outcome which we want. Okay. Now first tell me, what is the total outcome? That is 6. How? That's how many sample space we have. Number of sample space is nothing but your total outcomes, which is 36. What is the favorable outcome? So how many pairs do you think will be equal to or greater than 10? 6. So that is the probability. You can simplify. 1 over 6 is the probability of event that can occur. Okay. Now, what is the probability that the event will not occur? Again, use the same formula. Use the same formula. What is the outcome that event will not occur? First, write the total outcome as 36. 30. Right? Five by 6. So this is the probability of the event which does not occur. Okay. Next question. They are giving us some table and they are asking us to answer a few questions. Okay. So first, before you do anything, add these numbers. These numbers. And this. 50, 950, 134, and 866. It has to be correct. Tell me if it is wrong. Okay. Now, they are telling us to select one person who is having a positive test result. Now we know that the positive people, the people who are tested positive is 44, no matter whether it is true or false. So the total number of people who are tested positive are 134, right? Now we are supposed to select one person from that group. Okay. Now, before I start anything, what are the population value? What is the population value? How many people do you think are there? No, I mean total population. 1000, right? So probability of people who is tested positive will be equal to favorable outcome by total number of outcomes. So total number of outcome is 1000. We have 1000 people, out of which what is the probability of people who are tested positive? I mean, how many people are tested positive? 134. That's your favorable outcome. So 134 cannot be the total outcome because we are comparing that with the total population. Okay. So if I ask this question, that what is the probability that people who are tested truly positive among all the people who are tested positive, then the total outcome will be 134. Okay. Now here, or I can also write this in percentile, 13.4%. So among 1000 people, approximately 13% people are tested positive. Okay. Now answer this question. So they are saying that people probability of a subject who has a negative result, so I can say negative result, or it is or drugs, or. So or means addition rule. The formula is probability of negative plus probability of drug minus probability of negative and drug. Okay, I want you to answer this question. Right. Anyone with the same answer? Okay. Now, before I answer this, answer me this question. What is a total number of people present here? What is the total population? 1000, right? The total is 1000. Now, what is a total number of people who are tested negative? I'm asking about total. So total number of people who are tested negative. No. 866, right? Check with the column here, negative test result. So that's the total number of people who are tested negative. So total number of people tested negative is 866. Now people who have consumed drugs, do not see this one, okay? Don't see this. Just observe this and this. I just need the total numbers. Now tell me how many total number of people are subjected to drugs? 50, right? So 2 drugs equal to 50. Now we know that probability formula is favorable outcome by total outcome. So probability of negative is how much? The total is 1000 for all three. Total is 1000. Total number of people who are tested negative is 866. Out of 1000, 866 are tested negative. Plus probability of drug. What is the answer? 50 by 1000. What could be the answer now? We are saying that number of people who are tested negative but consumed drugs. It has to be both. 2 events, drugs and tested negative. Drugs and tested negative. 6. Drugs and tested negative is 6. So 6 out of 1000. It shares the same denominator. Now add everything. You must be getting 910 divided by 1000. Convert this into percentage. It is 91%. Okay? This is how you have to solve the addition rule problems. How do you identify whether it has to be addition rule or multiplication rule? Observe this. Okay? If it says or, that means you have to use addition rule. Those are like keywords. Multiplication rule. So here, according to this rule, probability of event or event A occurs for the first time and B occurs in the second time. They're not saying that one should occur or one should not occur. Now, probability of, for example, if I toss a coin once for the first time, I can get head. That is event A. When I toss a coin second time, I can get tails. That is event B. So when you combine these two events, the answer you get will be your probability A and B. So in this, they assume that event A will already be occurred. So when you say probability of A and B, order matters. Okay? A has already occurred and B is an event which is occurring. So that is called as multiplication rule. So you have to focus on the keyword and. Now we have two formulas for this. If A and B, the two events, if they are dependent, then this is the formula. If they are independent, this will be the formula. Now let us see what is meant by independent and dependent. So independent means as the name says, that two events A and B does not affect the occurrence of the other. So if there is an event A, that event will not occur any problem to the, that will not be a problem to the event B. There is no way it can affect. Such events will be called as independent events. So for this example, there are two families. So in first family, the baby which is born is a girl, and in second family, the baby which is born, the second baby, is also a girl. Now, what if the baby born in the first family is boy? Is it affecting anything, or is there any way this could change? No, right? It cannot change. There is no effect of event A. So this is called as, these events are called as independent. Or let me give another example. I'm tossing a coin twice, event A and event B. First time when I toss, I get heads. Or let me ask you. When I toss a coin, the probability is half, right? We all know that. When I toss a coin second time, the probability is again 1/2. Okay? Now, if I say, for example, if I say that this is 2/2, the probability is 2/2, which is 1. Is there any way it could change? Probability B is different. This is different. Now, if I say that I am going to throw a dice instead of a coin, so that could be 1/6, right? I'm not changing B event. So that doesn't mean that if I change A event, that doesn't mean that I have to change the B event. There is no way the event B can be affected by event A. So such events are called as independent. Now what are dependent events? It is nothing but if it is affecting, that is called as dependent. For example, high grades and a scholarship. Now, if your GPA is 3, it is definite that you will be getting a scholarship. Or if I say that the GPA is 1, there is no way you can get the scholarship, a merit scholarship, right? So this event, the change in event A is occurring change in event B. So those type of events are called as dependent. Okay, that is independent and dependent. So we have two formulas just given here, and both follows multiplication rule. Okay, I know there is too much, but I guess you have to understand everything step by step. Now this is nothing but if you have a sample and it says that the question says with replacement, then that is a keyword saying that those are independent events. If there is any keyword like without replacement, those events are called dependent events. So depending on this, you can choose the formula. Now let us solve this problem. Okay. Now according to the question, there is a quiz which consists of two questions. One is true or false. Okay. So true or false. True or false. There is only one question, true or false. And there is another question which has a multiple choice, A, B, C, D, and E. Now they are asking us the probability. They also have given the answer. The first answer must be true and the second answer must be C, option C. Now what is the probability that someone who guesses both answers should be correct? So what are the chances that someone can guess this answers and it has to be correct? So first let us construct the sample space. The first question might be true, answer is true. So a person can guess the answer as true, right? And he can guess the choices as A. So T, A. It can be true and you can guess the answer as A. Likewise, go on constructing the sample. False, option B, option C. So he has to guess this answer. It has to be true and option C. Now, how many options do we have? What is the total number of outcomes? 10, right? Now, what is the probability of someone guessing T and C both? He has to guess true and C, option C. So total number is 10, we know that. And how many favorable outcomes do we have? Only one. Can be only one. So 1. So this is one method of answering. Now we know that T and C and means multiplication rule, and we have the formula, right? P of T and C equal to probability of T into probability of C. How did I get this formula? From here. Assuming that the events are independent, you can choose this formula. Probability of A and B is probability of A times probability of B. Now what is the probability that it can be true? Okay, so before that, tell me what is the total number of outcomes for these two? 2 and 5. Why? Remember, true and false has only two options. True, false. So total number is 2. Now when it comes to multiple choice, we have 5. A, B, C, D, E. 5 options. So the total number is 5. Now what is the favorable outcome? It has to be true. In true and false, it has to be true. So 1. Okay. This is also 1. Out of 5, I need only C. So 1. So for example, if I say out of 5 multiple choice answers, I want the answer to be B and C. So B and C is what you want. So 2 outcomes. So it will be 2 by 5. Okay. So now in this question they are asking that C is the only answer. So there is only one favorable outcome. So it has to be 1 by 5. Now if you multiply these two, this is a multiplication sign. If you multiply, you will get 1 over 10. So there are two methods of solving. One thing is you can construct the sample space and you can answer the question, or else you can use the formula of multiplication rule. Now, why did I use only a multiplication rule here? Look at the keyword. It is asking for T and C both. Okay. So here, with replacement means, so with replacement means independent, without replacement is dependent. So this is independent, and dependent. Now answer this question. Answer this. It's a same example. You're supposed to choose 2 out of 50, and that has to be with replacement. That means independent. Now choose the formula among those 2 and find out the answer. Look at the keyword. It says and, so you have to use multiplication rule. In multiplication rule, we have 2 formulas. Which formulas to use is answered here. Independent. So if events are independent, you have to use the formula, second formula. Okay, you have to use the second formula if the events are independent. So now formula we know is A and B. Now what is A and B? A is nothing but a person who is tested positive. Now B is an event where a person is tested negative. So what is the probability that 2 persons are tested positive and also negative is the question. Positive and negative. Remember, whenever you're writing the probability or solving these kind of problems, always write the total number of outcomes first. Now we know that total number is 50. They say there is only 50 people, out of which we are supposed to choose 2. So keeping that aside, total number is 50, right? No matter the event is. Now event is positive. So what is the total number of people tested positive according to the given question? 44. It's given here. Positive test results are 44. And negative test results are 6, which is event B. That will be your answer. You have to get around right in fraction. 10.6%. Okay, this has to be the answer. Now solve the second question and tell me the answer. This is similar to that. This is the only difference is this is a dependent event. Now choose the formula and answer. So before we do this, probability of B by A is nothing but we want to check the probability of B assuming that A has already occurred. Now we have 2 places, right? 2 people. We have to choose 2 people. So first person and second person. And we have 50 total peoples, right? 50 is the total number of population. Now if I'm choosing one person here, this is event A, which has already occurred. Now we need to find the probability of P. So now, out of 50, I have already chosen 1 out of 50, right? Now what is the total number for P? What is the population left now? 49. So the only change will be in the total number of outcomes. Okay? Probability of A is nothing but same as before, 44 by 50 into, now the outcome is 49 because we have already chosen one person for event A. 6 by 40. Okay? So we will stop here and continue the rest on Wednesday.